Okay, kids, section 4.2, practice question 9. A 150-gram block. So I'm going to draw the block. Make sure I do this right. There we go. Here's the block. And it's 150 grams. Well, we don't like grams. So we're going to convert that to kilograms. So it becomes 0.150 kilograms. Is lifted from the floor to a shelf 2 meters above the ground. So here's the floor. Right, here's the floor. And then here's the shelf. And it's lifted upward, so it's going to have a displacement up is positive 0.2 meters. So it's lifted upward. And it says in 9A, the force needed to lift the block without acceleration. Well, we got to finish the free body diagram here. This is force of gravity, which is the mass times the gravitational field strength. It's also known as weight. Then we have force lift, and that's the only forces on it. Okay, that's it. You're lifting an object up. But what they did tell us is that as this object is being lifted upward, the acceleration is 0. It's not speeding up, it's not slowing down as it's being lifted upward. So we want to find the force needed to lift the box without acceleration. Well, we're going to use Newton's second law. Just because we're in chapter 4 doesn't mean we can forget it. So, oops, yeah, that happened again as soon as I move it. Isn't that? Always does that. Yeah, let's try it again. So, F net equals MA. This should be very familiar to you from the assignment. F net is equal to force of gravity plus force, I'm just going to call it L for lift. But what we're told is that the acceleration is 0. I can plug a number in there. Acceleration is 0. If the acceleration is 0, that means net force is 0. Has to be. So I can use that here, and look what it'll tell me. I'm going to use that information right over here. Look what it'll tell me. It'll tell me that 0 is equal to the force of gravity plus force lift, which means that negative force of gravity is equal to force lift. All I did was bring the force of gravity onto the other side. That's all I did. Oh, come on now, be a good computer. Oh, Nelly, why are you being like that? There we go. So I know the equation for the force of gravity. So I keep the negative sign, put M, G, and that would be force lift. So that's negative 0.150 kilograms times negative 9.8 newtons per kilogram is equal to force lift. So you get your handy dandy fancy dancy calculator out, right? See how Newton's second law helps us again? And I get 1.47. There's 2 negative signs there, so that'll make this a positive, which makes a lot of sense for the lift force to be positive, because the lift force is, so that's my substitution and my solution, because the lift force is upward. Okay, the lift force is upward. So we did 9A. I hope you guys are okay with that. All right. Now the work done by this force to lift the book up to the shelf. So hopefully you've gotten to this section. And analysis, the equation for work is equal to force dot product displacement. I've given you a lesson about this. And we want to find the work done by the lift force. So look, this is very important. I'm finding a very specific work, the work done by the lift force. So work by the lift force. I'm going to add L's here. Not just any old work, the work done by the lift force. So then I put in the recipe for this. It becomes the magnitude of the lift force times the magnitude of the displacement times the cosine of the angle between them. That's the recipe. Okay, well, let's take a look at these two forces, right? I'll redraw it right here. The lift force is straight up. The displacement is straight up. So the lift force and the displacement are parallel to each other and in the same direction. So if you got two lines that are parallel and in the same direction, and someone asks you, what's the angle between those two parallel lines in the same direction? I hope you realize that the angle between them is 0. So now I can substitute work lift magnitude of the displacement force, 1.47 newtons. Magnitude of the displacement, well, it's a displacement of positive 2 meters upward. Cosine of 0. Now, I hope you all know that the cosine of 0 is, put it in your calculators. I'm talking to the kids in class here. Come on, kids. Cosine of 0. Do it. It's good practice for you. Cosine of 0. What do you think? Amy? 1. The cosine of 0 is 1. So this just becomes 1. So then I type into my calculator 1.47 times 2, and I get my solution. Work done by the lift force. See how specific I'm being? The work done by what force? The lift force. You have to be specific. The work done by the lift force is 2.94, and that would be a J for a joule. You notice we've taken two vectors and multiplied them in a new and special way so that we end up with a scalar. Work is a scalar, so I don't need to put a direction in there. Scalars don't have direction. 2.94 joules. Okay, you can, if you do have a positive or negative sign in there, specifically a negative sign, it's meaning that you've done negative work, but that's not a directional sense. Okay, that's have you given the object energy or have you taken energy away? So don't make that confusion that a lot of kids do. I hope this helped. Helped? Okay. Have a great day. Bye.